For questions 1 through 3, the directions say, if tangent of alpha is 5/12 and alpha is in the third quadrant, define each value. So before we do any of these specific problems, we know right away that y is 5 and the x is 12. We have to know what r is so we can finish this problem. So if we draw this in quadrant 3, which it says it's in, x turns out is not actually 12, it's negative 12. And y isn't 5, it's negative 5. We know that because in quadrant 3 we're going left and down. So we're missing r. If we use the Pythagorean theorem, x squared plus y squared equals r squared, x being negative 12, y is negative 5, r is unknown. Negative 12 squared is 144, 5 squared is 25, 25 and 144 is 169. Therefore, r is plus or minus 13. The radius is always positive, so it's positive 13. So as we proceed through questions 1 through 3, we have to use the fact that x is negative 12, y is negative 5, and r is 13. Number 1, we're supposed to figure out what sine of 2 alpha is. Using the double angle identity, that's going to be equal to 2 sine of alpha times cosine of alpha. As we've already discovered, we know what y, r, and x are. X is negative 5, r is 13. Pardon me. Y is negative 5. Sine is y over r. Cosine is x over r. X is negative 12, and r is 13. So to proceed with this problem, we're going to replace sine of alpha with negative 5/13. We're going to replace cosine of alpha with negative 12/13. Simplifying this, negative 5 times negative 12 is 60. 13 times 13 is 169. Multiplying a whole number 2 times a fraction, you multiply it by the top only. If your fraction reduces, you shall reduce it. Our fraction does not reduce. Therefore, sine of 2 alpha is 120 divided by 169. Number 2, we're supposed to figure out what sine of alpha divided by 2 is. It's going to be equal to plus or minus the square root of 1 minus cosine of alpha divided by 2. As previously mentioned, we already know what cosine of alpha is because we know that x is negative 12 and r is 13. So replace that into our equation. In place of cosine of alpha, we're going to put negative 12/13. I'm going to change the 1 that's in front of that to 13 over 13. That way I have common denominators and I can put those together. 13 minus a negative 12 is like 13 plus 12, which is 25. Denominators stay the same. At this point I have a complex fraction, which I don't want. So I'm going to multiply the top and bottom of this fraction by 13. Lots of different ways that you could proceed from here. That's one option. In the numerator, the fraction, the 13s cancel, so you get 25. Sorry, I wrote my plus or minus here in the wrong spot. Plus or minus radical 25, and then 2 times 13 is 26. To proceed from here, we have to square root the numerator and square root the denominator. That's how you square root a fraction. The top is a perfect square. Square root of 25 is 5. The denominator is not a perfect square, so you leave it as square root of 26. To rationalize your denominator, you multiply the top and bottom by the square root of 26. It's going to give us 5 square roots of 26 over 26. Now, the last thing we have to decide is this answer positive or is it negative? Because right now we have plus or minus. It can't be both. So since we're told that the original angle, alpha, from the directions is in the third quadrant, that means that alpha has to be bigger than 180, but less than 270 degrees to be in the third quadrant. If you divide each of those three things by 2, you get 90 degrees is less than alpha divided by 2, which is less than 135 degrees. Since the angle that we're using here is alpha over 2, that means we're looking at this situation here. Alpha over 2 is bigger than 90, but less than 135. That's in quadrant 2. In quadrant 2, your x value is negative, your y value is positive, and your r value is positive. Sine, which is what this question is asking for, sine of alpha divided by 2. In quadrant 2, sine is positive because both your y's and your r's are positive. So the final answer is 5 square roots of 26 over 26. And I'd like you to say why it's positive. It's positive because alpha over 2 is in quadrant 2. That concludes that problem. Number 3, you're supposed to figure out what tangent of alpha over 2 is. We previously figured out a couple of things. First of all, tangent of alpha over 2 is sine of alpha divided by 1 plus cosine of alpha. We've already figured out what sine alpha was. It's y over r, which is negative 5/13. We figured out what cosine of alpha is. It's x over r, which is negative 12/13. If you substitute those values into this, we're going to get negative 5/13 divided by, I'm going to not put my 1 in until the end so I can have a common denominator, negative 12/13. I changed the 1 to 13 over 13. Then I simplify this. 13 plus negative 12 is 1. And then this needs simplified, which you can do in lots of different ways. One method would be to multiply the numerator and denominator by 13. That's the same as multiplying by 1. It's going to give us negative 5 over 1, which of course is negative 5. So tangent of alpha divided by 2. So, pardon me, running out of space down here. It's equal to negative 5. So that concludes number 3. Number 4, you're supposed to use a half angle identity to find the value. So it's sine of 105. A half angle identity means that we're going to have some angle divided by 2, and that angle divided by 2 has to be equivalent to 105. So if we double 105, we get 210. In other words, 210 divided by 2 is 105. So these are equivalent angles. Using the half angle identity for sine, we get plus or minus radical 1 minus cosine of our angle of 210 degrees over 2. What is cosine of 210? 210 is in quadrant 3. Makes the reference angle 30. Opposite 30 then would be negative 1 because we're going down. Opposite 60 would be negative square root of 3 because we're going left, and it makes R2. So cosine of 210 is going to be negative square roots of 3 over 2. So I can put that into my radical. I'm going to change the 1 then to 2 over 2. We have common denominators for our fractions, so that's going to be 2 plus the square root of 3 over 2. This is over 2. If we multiply the top and bottom of the fraction by 2, those 2's cancel, and we end up with plus or minus the square root of 2 plus the square root of 3 over 4. Square root the top and the bottom. Top is not a perfect square, but the denominator is. So anyhow, as I was saying, if you square root the top and square root the bottom is a perfect square, which makes 2. Top is not a perfect square, so it's the square root of 2 plus the square root of 3. We have to determine if it's positive or negative. So the original angle is 105, which is in quadrant 2. In quadrant 2, y is positive, x is negative, and r is positive. This is sine, so it's a positive over a positive, which makes it positive. So our final answer is sine of 105 degrees equals positive square root of 2 plus the square root of 3 over 2. Number 5, we're supposed to use a half angle identity to find each value. So since this is tangent of 195, we're going to double the 195. Put that on top, which would be 390, and divide that by 2. That makes it a half angle identity. 390 divided by 2 is the same as 195, and a half angle identity means you have some angle divided by 2. Well, the half angle identity for tangent is sine of the angle you're dividing by 2, which is 390, over 1 plus cosine of the angle that you're cutting in half. So cosine of 390. We got to figure out what sine and cosine of 390 is. 390 is 30 degrees past 360. That puts us in quadrant 1. That's 390 degrees. Opposite 30 is 1. Opposite 60 is the square root of 3. Opposite 90 is 2. Sine of 390, therefore, is 1/2. Cosine of 390 is square root of 3 over 2. I'm going to change my original 1 to 2 over 2. Adding my fractions together, since I already have common denominators, I'm going to get 2 plus the square root of 3 over 2. I multiply the top and bottom of the fraction by 2 to get rid of these dividing by 2's. And to put the 1 over 2 plus the square root of 3. We need to rationalize the denominator. To do so, we're going to multiply the top and bottom of the fraction by the conjugate of the denominator. It's going to give us 2 minus the square root of 3 over. When you multiply two conjugates together, you get the first term squared minus the last term squared. So it's going to be 4 minus 3. So then that simplifies to 2 minus the square root of 3 over 1, which of course is 2 minus the square root of 3. So tangent of 195 equals 2 minus the square root of 3. Number 6, we're supposed to use a half angle identity to solve this. So sine of 7 pi over 8. You take the angle you're given and double it. 7 pi over 8 double to 7 pi over 4. Then divide that by 2. That's going to be equal to plus or minus radical 1 minus cosine of the angle you're cutting in half, which is 7 pi over 4, all over 2. We need to know what cosine of 7 pi over 4 is. 7 pi over 4. Let's see. If we start here at 0, one complete revolution would be 8 pi over 4. That reduces to 2 pi, which means 7 pi over 4 is really close to that. It's almost 8 pi over 4. In fact, we're pi over 4 pi short. We're 1/4 of a pi short of being 8 pi's over 4, because 7 pi over 4 plus 1 pi over 4 is 8 pi over 4. Pi over 4 is a special right triangle, 45, 45, 90, which makes the legs 1, negative 1, and the hypotenuse square root of 2. Cosine of this would be 1 over the square root of 2, which rationalizes to square roots of 2 over 2. So back into my equation, this plus or minus I'm going to change my cosine of 7 pi over 4 to square root of 2 over 2. I'm going to change my 1 to 2 over 2, so I have a common denominator. This is all divided by 2. So it's going to be 2 minus the square root of 2 over 2 divided by 2. I multiply the top and bottom of the fraction by 2. It makes it so it's not complex anymore. 2 divided by 2 gives you 1. 2 times 2 is 4. If we square root the top and square root the bottom of this fraction, the top is not a perfect square. The bottom is. The only thing left to decide now is this a positive or negative answer? To determine that, you take the original question, sine of 7 pi over 8. 7 pi over 8 is almost 8 pi over 8. 8 pi over 8 is the negative x-axis. So that's in quadrant 2. In quadrant 2, your x value is negative, your y value is positive, and your r value is always positive. Sine is y over r, so it's a positive over a positive, which is a positive. Therefore, sine of 7 pi over 8 equals positive square root of the difference of 2 and square root of 2 over 2. We want to say why it's positive. It's because sine is positive in quadrant 2. Finished. Number 7, the direction to verify each of the following is an identity. There's a couple things that I notice right away. The right side's denominator is equal to secant squared of a. And then continuing, secant's on the bottom of the fraction. If I want to make it on the top, I just use its reciprocal. The reciprocal of secant is cosine. So this right side just becomes 2 cosine squared of a. On the left, I recognize cosine squared of a is the same as cosine squared of a minus sine squared of a. As I continue, I look at the right side, it only uses cosines. The left side, I have this sine squared in it. So somehow I got to get rid of that sine squared. I can do so by substituting it with 1 minus cosine squared of a. That comes from the Pythagorean identity, sine squared of a plus cosine squared of a equals 1. And if you solve the equation for sine squared of a, you get 1 minus cosine squared of a. Getting rid of my parentheses, I'm going to have 1 plus cosine squared of a minus 1 plus cosine squared of a. 1 minus 1 gives you 0. Cosine squared of a plus cosine squared of a is 2 cosine squared of a, which is what the right side is. So we are finished. Number 8, the directions are verify that this is an identity. The right side, I notice, is cosecant of 2a, which I don't care for. I'm going to make it sine of 2a, because cosecant and sine are reciprocals. So I didn't change it to sine. I should say I changed it to divided by sine of 2a. Sine of 2a is a double angle identity. It's 2 sine of a cosine of a. Since we're multiplying the numerator and denominator by 2, those cancel, which gives you 1 over that denominator. 1 divided by sine of a cosine of a. If I don't want that to be a fraction, that becomes cosecant of a times secant of a, because those are the reciprocals of sine and cosine. That's what the left side was all along, so we're finished. Number 9 was to verify that this is an identity, which means make the left and right sides equal. I recognize the numerator on the right side, that's a double angle identity. Becomes 2 sine of x cosine of x. I recognize in my denominator cosine of 2x, which I'm subtracting, so if I replace this, I need to use parentheses. That becomes cosine squared of x minus sine squared of x. If I get rid of my parentheses, By distributing the subtract, I get 1 minus cosine squared of x plus sine squared of x. At this point, there's nothing obvious for me to do. And when things get not obvious, I start looking at the left side, which is cosine of x. I know cosine is, it's cotangent of x. I know cotangent is cosine over sine, which means on the right side here, I need to somehow get rid of this sine so it's not there anymore. To do that, I want to make sure that the bottom doesn't have any cosines in it, but has sines in it, so I can cancel it with that sign that's on the top. Well, here's what I recognize. Hopefully you do too. 1 minus cosine squared of x, that's the same as sine squared of x. That comes from a Pythagorean identity solved for sine. That's helpful because in our denominator we can add those sine squareds together. Get 2 sine squared of x. It's helpful for lots of reasons. One, we can then divide the numerator and denominator by 2. We can divide the numerator and denominator by sine, and we are left with cosine of x in the numerator, sine of x in the denominator. That's equal to cotangent of x, which is what the left side was all along. So we are finished with that problem. Number 10, we're supposed to verify this is an identity. That means make the left and the right sides the same. On the left, I recognize that we have sine of 2b. That's a double angle identity. That is 2 sine of b cosine of b, which at this point is not all that helpful. So inside my parentheses, I'm going to change cotangent of b to cosine over sine of the angle b. I'm going to change tangent to sine of b over cosine of b. Then I'm going to add those fractions together, hoping that good things will happen. First fraction, I'm going to multiply the top and bottom by cosine. It's going to give me cosine squared of b over sine of b cosine of b. Second fraction, I'm going to multiply the top and the bottom by sine. It's going to give us sine squared of b over cosine of b. I did that so I have common denominators. Once you have common denominators, you add those together. To add two fractions, you add the numerators together. Bottom numbers, the denominators stay the same. I recognize that my numerator is just 1. It's one of your Pythagorean identities. Then we are multiplying by sine of b and dividing by it. We're multiplying by cosine of b and dividing by it. So we're left with 2 times 1, which is 2, which is what the right side was all along. Finished. Supposed to verify this as an identity, which makes both sides the same. Currently, the right side I wouldn't know what I would do with. So let's start with the left. We don't have a half angle identity for cotangent, but we do for tangent. So I'm going to make this 1 divided by tangent of alpha over 2. Half angle identity for tangent would be sine of alpha over 1 plus cosine of alpha. And then if you have 1 divided by a fraction, that's equivalent to 1 times the reciprocal of that, which is because we can multiply the top and bottom of this fraction by 1 plus cosine of alpha over sine. So it's going to give us 1 plus cosine of alpha over sine of alpha, which is similar to the right side, but it's also not. Need to get sine on the top somehow. So here's what I would do. I know that 1 minus cosine squared of alpha is sine squared of alpha. So to get the top to be 1 minus cosine squared, I'm going to multiply the top and the bottom of this fraction by the conjugate of the numerator. I know if I do that, it's going to give me the top to be 1 minus cosine squared, which I know is going to be helpful. or at least I think it's going to be. The denominator is just going to be sine of alpha times 1 minus cosine. I'm not going to multiply that out, because if I look at the right side of the equation, it's 1 minus cosine of alpha. And if I look now, I have 1 minus cosine of alpha. So that's very encouraging. 1 minus cosine squared of alpha is sine squared of alpha. It's Pythagorean identity. I'll leave the bottom the same. My writing is starting to take a turn for the worst. Now I can divide the numerator and denominator by sine, which makes it sine of alpha over 1 minus cosine of alpha, and it makes the right side what it was all along. So we are finished. Just to verify that this is an identity, which means make the left and right side the same. The left side is a double angle identity. The numerator is going to be cosine squared of A minus sine squared of A. The denominator is also a double angle identity, after the 1, of course, which would be 2 sine of A cosine of A. At this point, the left side frightens me. Some different ideas on the left. I could change cosine squared or sine squared of A in the numerator to the other sine or cosine using the Pythagorean identity. I don't know how helpful that's going to be, so I'm going to stop with the left side. The right side, there's lots of things I can do, or lots of work to do. I can change cotangent to cosine over sine. And I'm going to change the 1 to sine over sine so I can subtract those two fractions. Do something very similar in the denominator, but it's a plus. I add or subtract my fractions together. Then to make it so it's not a complex fraction, I can multiply the numerator and denominator by sine of A. Cancels sine of A's in lots of places, giving us cosine of A minus sine of A over cosine of A plus sine of A. At this point, I wouldn't know what to do if I didn't have a left side. The left side, the numerator says cosine squared minus sine squared. So I don't have squareds in the top. So I'm going to multiply the top and bottom of this fraction by something that will give me cosine squared of A minus sine squared of A, which is the conjugate cosine of A plus sine of A. That's going to give me, I'm going to have to erase some things here to continue. It's going to give us cosine squared of A minus sine squared of A. The middle two terms of that multiplication end up canceling out. The denominator is going to give us cosine squared of A plus 2 sine of A cosine of A plus sine squared of A, which gets us closer because our numerators are identical. The left side and right side of the equation. The only difference between the denominators is the left side has a 1, the right side has cosine squared plus sine squared, which of course is 1. At this point, both sides are the same, so we are finished.